Hi, I'm Roland Vos from the BimlFlex team at Verigence, and I will provide a quick overview of Verigence's flagship data solution automation platform called BimlFlex. BimlFlex is a model-driven data solution automation platform that generates data integration code and processes aimed at the Microsoft data stack, as well as the necessary scripts and workflows to automate the deployment. Much like making art with clay, shaping your data to retrieve insights from it is a process that often requires adjusting the way we interpret it. Our understanding of our data, its meaning, and how it can be used, is only as good as the understanding of the context in which it was created, stored, and managed. Because of this, modern data solutions must be able to easily change their interpretation of the data, as implemented through the data model and the way we transform our data into this. This requires flexibility in the way we create our data logistics. The ability to generate these data logistics processes, as opposed to manually developing these, and automating the workflows to deploy and run them, are essential to meet these requirements. With BimlFlex, Verigence seeks to bring affordable data solutions to companies of any size through automation. We want our customers to spend less time preparing data and more time using it to drive their business. BimlFlex accelerates and automates end-to-end data solutions for the Microsoft stack using modern visual interfaces. This means you can deliver your data solution for these technologies without writing a single line of code. BimlFlex is the only solution that natively supports and fully harnesses the power of Azure Data Factory and SQL Server integration services. Only BimlFlex lets you automate a data solution, including all data pipelines, data flows, and SSIS packages, as well as any other supporting components such as database projects, link services, and stored procedures. BimlFlex allows you to define and generate your data solution. In its most basic form, you would ingest data from any data source that is supported by Azure Data Factory or on-premise SQL Server Integration Services or SSIS, and then process this in Azure Data Factory using execute pipelines or mapping data flows or using your Databricks cluster. The data itself can be stored on the supported platforms, which include the Microsoft family of SQL Server databases, Azure Synapse, Snowflake, or storage accounts, including Delta Lake. BimlFlex will generate artifacts for these that are native to the technology in question. For example, ADF pipelines, link services, mapping data flows, SSIS packages, scripts, or stored procedures. The deliverables to deploy the databases, schemas, and everything associated with this are also generated, including the scripts that are necessary to integrate this in DevOps workflows. To design your solution, you can use the BimlFlex application to import the source structures, the metadata, and then define your target models in a number of ways, and for a number of architectures. For example, you can apply business modeling to define holistic and agreed terms and definitions of your most important data. You can use this with predefined approaches such as ensemble logical modeling, ELM, or industry reference models. And you can configure your own approach. We believe that business modeling is core to delivering lasting and manageable data solutions, and the resulting entities can be used to map your data to for a business and model-driven data solution. The imported definitions will represent connections to the data when the data logistics processes are generated, and these data objects can be mapped to create data vault models and/or data marts following dimensional modeling concepts. When working with BimlFlex, we recommend an iterative approach. The design, the metadata of the data solution can be configured in the BimlFlex app. The provided build pipelines can then be run to compile and deploy the solution to the designated target platform where the processes can be run. At that stage, the results can be viewed in the target platform or database, where the data is available as per the designed model or structure. If any changes in the design are necessary, these can be made in the app, but BimlFlex also provides an extensive authoring suite where modifications or overrides to the use patterns can be implemented. BimlFlex contains a fully fledged integrated development environment or IDE, where parts of the solution can be changed using Bim Script Syntax. Behind BimlFlex sits a fully featured domain-specific language called Biml, and this makes it easy to specify any customizations you can think of, as long as this is supported in Azure. These modifications are saved with the solution, and BimlFlex will compile this in deliverables that are native to the target infrastructure. BimlFlex is subscription-based, so if you're happy with the output, you can suspend your subscription while still continue to run your data solution. This is because BimlFlex produces output that is native to the target infrastructure, and after deployment, this will continue to run independently of the BimlFlex design environment. So let's switch over to BimlFlex for a quick look at the app and the end results. What we see here is the BimlFlex dashboard. The dashboard gives an overview of the data solution as a whole, and is a starting point to work on the design. The first thing to look at is the connections. The connections editor allows you to see which data objects or objects are associated with each connection and point to all the different data sources you want to integrate into your data solution. It is at this level that you can add additional definitions by importing metadata, connecting to your data files or data sets. The connections give you an overview of all the data sets that are involved in your solution. But what to do with it, that's the domain of the project. The project editor defines where information should be sourced from and then what to do with it. In this particular example, data associated with this particular source connection will first be staged in the stage connection, then go to a persistent staging area, and ultimately will be loaded into a data vault. And this can be done using a specific integration template, such as, for example, an Azure Data Factory approach. This will direct the compiler to generate execute pipelines, and if we would select something else, we would get Azure Mapping Data Flows. Once we have an idea on the flow of data, we can start looking into the models a little bit further, and this is what we can do in the business modeling feature. The business model feature is where we design generic terms and definitions that are meaningful to the people involved in the data projects. It's a way to get everybody on the same page, and it supports structured modeling approaches such as ELM. In an initial canvas, we can define the data objects we're interested in and also what their relationship between the objects. For example, we can say a bike is the same as a product, so we can add synonyms and make and define relationships between data this way. But you can also say that an address is a property of a client, so we can attribute this to, in this case, the client concept. Defining the model like this allows us to zoom into individual events and define the relationships that are strictly associated with these events. And that in turn create initial diagrams we can start to discuss and also use this to draw additional relationships between data we haven't thought of before. The business model can then be mapped to data using the Data Vault Accelerator. The Data Vault Accelerator allows us to morph the data structures that we get into the target model that we intend. And there's a couple of things we can do here. It is at this level we can map objects to the business objects we defined earlier. For example, if we associate the customer to client, then the hub customer core business concept will inherit all the information from the business object. And we can further discuss how we can split satellites, add additional relationships, and ultimately define a data vault model that we're happy with and that serves the purpose and is aligned to our business model. BimlFlex also provides a schema diagram that allows us to look into additional details and establish different relationships between data sets. BimlFlex also provides a data lineage feature where we can look at the relationship between the data flows and also to understand where data is going to across different data objects. If we're happy with the design and we've mapped the data to the models, it's time to look at the output. We can switch to Biml Studio, which is the development environment that allows us to peek behind the scenes to see what kind of code is made available before we actually go into Azure to look at the end result. Biml Studio interprets the metadata in our repository and provides a live preview of the solution we would get if we would go ahead and compile this into Azure artifacts. And what you can see here is the Bim Script Syntax, which is a clear explanation of the structure of the data integration processes that will be generated following the design that we've just configured. And it is here that we can use overrides and customizations to tweak the templates that are automatically generated by BimlFlex. If we build this, which is the compile process that BimlFlex supports, various Azure artifacts will be created, including ARM templates and JSON files and everything we need from the scripts and every script we need to deploy this into Azure Data Factory. Within Data Factory, we can see that a lot of artifacts have been made available. For example, pipelines, dataset, and mapping data flows. All this is generated automatically by BimlFlex, and it will always be up to date with what works in Azure, because the Biml language is always being kept in sync with what Azure supports. So it's not something that you need to worry about. This is what BimlFlex will do for you. Every time anything new is supported in Azure, simply regenerating all the artifacts and deploying it into Azure will be sufficient to make sure that the templates are optimized for what Azure can do. BimlFlex will generate all the logistics necessary depending on the templates that are used and selected in the design environment. As you can see, the code is generated native for Azure, in this case using mapping data flows. At this stage, everything runs in Azure, and BimlFlex is no longer required unless you want to make changes to your design. This concludes this brief overview of BimlFlex. If you're interested, there are many resources available online. And of course, please reach out to us for a demonstration, trial, or subscription to any of our powerful automation solutions.